We're continuing solving quadratics, and today we're going to solve by the quadratic formula. So when all other methods fail, we can always use the quadratic formula. It's just that we don't like to use it if it's not needed because it takes longer. So the quadratic formula gives us solutions of x is equal to negative b, or the opposite sign of b, plus or minus the square root of b squared minus 4ac. All of this is under the square root, so we have to do all that before we take the square root, and the whole thing is over 2a. So again, it has to be equal to 0, so I'm going to minus this 10x. And now a does not have to equal a positive number, just so you know, because we could plug in negative a into the quadratic formula. For every other method we did, we needed a to be a positive number. So here my a is 10, my b is negative 10, and my c is 3. So we're going to go in, I'm going to say x is equal to the opposite of b, plus or minus the square root of b squared minus 4 times a times c, and the whole thing is over 2 times a. So the first things first, we're going to get a positive 10 plus or minus the square root. This is 100 minus, right, only one negative, 40 times 3 is 120, and the whole thing's over 20. I can go a step further here and say 10 plus or minus the square root of negative 20 over 20. I need to reduce the square root of negative 20. So we know it's going to have an I because it's got the negative 1. And it's also 4 times 5. So this would be 10 plus or minus 2i root 5 all over 20. This part gets a lot of people. I can only reduce if the number goes into everything. So 10, 2, and 20 all have a common factor of 2. So that's all I can divide by. So 10 divided by 2 is 5. 2 divided by 2 is 1, so that's just I left there. And 20 divided by 2 is 10. This is the lowest this would go. And just like with when we were solving by square roots, we can separate this and say 5 plus I root 5 over 10, 5 minus I root 5 over 10. We could also keep it all together like this. Let's do another one together. So I'm going to minus the 2x and add the 2x and add the 1. So that's minus 6x plus 1 equals 0. So the a is 9, the b is negative 6, the c is 1. So opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be a positive 6 plus or minus the square root of 36 minus 4 times 9 is 36 times 1 is 36 all over 2 times 9, which is 18. So this is 6 plus or minus the square root of 0 over 18. And the square root of 0 is just 0. So 6 plus 0 and 6 minus 0 are both just 6. So we have one answer, 6 over 18, which is 1/3. All right, so there's 2 for you to try. You can pause. Answers are posted in our Google Classroom in the blank notes. A key feature of the quadratic is called the discriminant, and that is what the part under the square root is called. Knowing what that value is can tell us how many solutions and the type of solutions. So if I have a positive discriminant, right? It's a positive number in there. That means there are going to be 2 real solutions, 2 real. And what that would look like here, it would be crossing it twice, crossing the x-axis twice, when we get 2 real solutions with a positive discriminant. When it's equal to 0, right, we're going to only have 1 real solution. When it equal to 0, it just grazes it, just touches it the once, doesn't go through it twice like this one did. So that's what the graph would look like when there's only one real solution. But here, if it's a negative, right, less than 0, it never crosses the axis at all. So it has no real solutions, but it does have two imaginary or complex. They do use the word imaginary, although technically I guess the word would be complex solutions. So in this example, we just want to find the discriminant and determine the number and type of solutions of the equation. So this is already equal to 0. So A was 1, B was -6, and C was 10. So doing B squared minus 4AC gives me 36 minus 40, which is -4. A negative discriminant will be two imaginary solutions. For B, it's not equal to 0 yet, so we're going to add that 9. So now it's going to be B squared minus 4, A is 1, C is 9. So this is 36 minus 36, so that's 0, which means we have one real solution. For part C, I have A is 1/2, B is 1, C is -1, so B squared minus 4 times A times C. So 1 squared is 1. I have two negatives, that's going to be a plus. 4 times 1/2 is 2, times 1 is 2. So my discriminant is 3, positive number, 2 real solutions. So we have some NJGPA practice. So determine whether the equations shown have real solutions or non-real solutions. Record the equations in the correct box. So basically we would find the discriminant of each of these. So we know whether it's going to be real solutions, which would be positive or 0, or no real solutions, which would be a negative discriminant. So for our first one, we move that over, we really have a +1. So B squared minus 4AC, 4 minus 16 is -12, so that would go into the not real solutions. 4x squared minus 2x equals -1. For this one, if I added the 3 over, we're going to get 6 squared minus 4 times 3 times 3. So 36 minus 9 times 4 is 36. This one is 0, so we know it has at least one real solution. And our last one here, it's already ABC. So B squared minus 4AC is positive 25 minus 4 times 7 is 28 times 2 is 56. So that's negative. We don't even need to know what the negative number is, right? It's -31, but it's irrelevant because it's negative. That would go here. 2x squared minus 5x plus 7 equals 0. Right, in the equation shown, P is a constant. If the equation has no real solutions, which could be the value of P, select all that apply. So we know if it's going to have no real solutions, the discriminant, B squared minus 4AC, would have to be negative. It would have to be less than 0. So we're going to take this, and I'm going to plug in my B, which is now P. My A is 2. My C is 4. So P squared minus 32 is less than 0. If I add the 32, P squared is less than 32. But here's a little bit of a problem. Because I get plus or minus, I can only do the absolute value answer. So it's the absolute value of the square root of P squared. think that's what I'm trying to get at to say. We'll solve it and then we'll see. So if I took the square root of both sides, I'm going to get P is less than, and this comes out to be about 5.6. Repeat. But I can't put plus or minus here. So instead, the absolute value of P has to be less than 5.6 repeating. So if I put negative 10 in, the absolute value of negative 10 is not less than 5.6, so negative 10 is not a solution. Negative 5, the absolute value of negative 5 is 5. 5 is less than 5.6 repeating, so negative 5 works. 0, if I put 0 in, the absolute value is 0, 0. 0 is less than 5.6 repeating, so that works. Actually, I'm not sure if it was repeating. I should double check that. I wrote 6, 6 on my paper, and I'm now thinking it's not actually. And I don't want to mislead you. Yeah, it's not. We're just going to get rid of that bar. And just call it 5.66. Okay. 5 is less than 5.66, but 10 is not, so 10 is not out. So these three could be values of P. For 3, which equation has non-real solutions? So which one has a discriminant that is negative? So here we don't really care again what the actual number of the discriminant is. We just care if it's going to be positive, negative, or 0. So if I did b squared minus 4ac, this is going to be a plus something. Positive plus a positive is going to be a positive, so that's out. For b, this is promising. We have a 9 minus something big, right? 16 times 3 is 48. So this is going to be negative. So that definitely has no real solutions. I would double check the others just to make sure I didn't make a mistake. So b squared minus 4ac. We get 144 minus 4 times 4 times 9 is 144. So this is 0. That's out. And then b squared minus 4ac. This is going to be a plus, right? So positive plus positive, that's out. For 4, which of the equations could have solutions that are non-real? So which could have i's in them? Anytime you're just taking the square root of something, you can have an I, because that something could be negative. So that's there. And I would also say that's there, because the final step in this one is going to be taking the square root of something, and it's possible that what we're taking the square root of is negative. Here, this technically is x times ax plus b. And there's no way to get an I here. So that's out. This could, right? Because you could have to use quadratic formula on this, and we know we can get i's on quadratic formula. So that's possible. But this, written already in factored form, ax plus b being set equal to 0, there's no square root to take, so that's not going to end up with an I. Here, to set this equal to 0, there's no square root to take, so that's not going to end up in I. So it's these three. And now let's look at some applications. So Max launched a bottle rocket, and its height could be modeled by this function. H represents the height of the rocket in feet, and T represents the time in seconds. So when does the rocket hit the ground? Well, it hits the ground when the height is 0. So we would set 0 equal to this side. So you're welcome to deal with smaller numbers if you want. Try to take out a GCF first, but I'm just going to go with what I have here. So I'm going to do my quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So this is going to be negative 32 plus or minus. So this was 1024 minus 4 times negative 16 times 64. So plus, actually ends up being 5,120. over negative 32. The square root of 5,120 is 71.6. And now I would do negative 32 plus 71.6 divided by negative 32. I would get a negative answer there, so that's going to be out. Negative 32 minus 71.6 over negative 32 comes out to be a positive number, 3.2. For B, when does the rocket reach a height of 20 feet? So now we're going to plug 20 in for this side and solve. So if 20 is equal to negative 16t squared plus 32t plus 64, I think that's what it was. Yep. So when we minus the 20, that changes our C value. So again, we would go through our whole process, negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So this ends up being the square root of 3,840. Skipping some work here to show you. The square root of 3840 would have been 61.97. So if I try negative 32 plus that over negative 32, I get negative 0.9, not great. Negative 32 minus 61.97 over negative 32 gives me a positive 2.9. So there's one here for you to try. You can pause. Answers posted in Google Classroom. Example 4. The length of a rectangle is 5 more than twice its width. The area of the rectangle is 250 square meters. Find its dimensions. So we know that the width is what they've talked about. The length is 5 more than twice it, so do 2w plus 5, and it's equal to the area of 250. So this is going to be 2w squared plus 5w when I distribute, and I'll minus the 250. There is no GCF available for this one, so we were just going to have to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be negative 5 plus or minus the square root of 25 plus 2,000, so 2,025. The square root of 2,025 is actually, that's perfect square. So negative 5 minus 45 is going to give me a negative over a positive, so that's not going to work, so I'm going to focus on the positive. Negative 5 plus 45 is 40 over 4, so that would be 10. And that's what W was, right? So my width is 10 meters, and my length, which would be 2 times 10 plus 5, would be 25 meters. And 10 times 25 is 250, so that works. Yay! Here's one final one for you to do. I know it doesn't say find the dimensions, but that's what we are looking for there. And that's it. That is the end of solving by quadratic formula.